Well, hey guys, I wanted to talk to you a little bit about instrumentation. And when I say instrumentation, I mean some of the basic tools and materials you would be using in a lab. Whether it's biology, could be chemistry, so forth and so on. One of the obvious ones in biology, of course, would be a microscope. It's a little difficult to do a virtual microscopy type lab. But that being said, we'll go ahead and kind of work a little bit here with some glassware, in this case beakers and a triple beam balance. And when I say we're going to play around with this a little bit, we're going to measure the mass of water. Okay? Fair enough, right? Easy peasy, lemon squeezy, here we go. Okay, so the mass of water goes something like this. 1 mil of water should weigh, or should have a mass rather, of 1 gram. I'll say that again. That's our background. That is super duper important, right? 1 mil of water should have a mass of 1 gram. So, with that said, if 1 mil of water has a mass of 1 gram, what do you think the mass of 50 mils of water is going to be, right? What is the mass of 50 mils? Well, it should be, right? Our hypothesis states that it should be 50 grams, okay? And that's what we're going to do. We're just playing around measuring a few things, and we're going to see if we get 50 grams of water. So that's our background there, okay? This is the beaker we're going to be kind of playing around with. Let's get the mass of this bad boy, all right? Let's balance it around a little bit. Maybe right around there. I'm going to round this slightly. Let's just say we've got 56. I'm going to write that down, right? 56. Oh, I am a weird stickler for units, okay? It's 56 grams, not inches, not yards, not miles, not degrees. It's 56 grams, right? You got to get that down. Okay, so we got the mass of the beaker by itself. Now we're going to have to add in the water, because obviously I couldn't put water on there by itself. You can't do that. That's why we're using the beaker. So I got to get around 50. All right, you see what I'm doing here? Well, obviously it's a little bit past that line, so I got to use my little cheapo pipette and scoop a little bit out. I got to get right to that meniscus, right where the level's just about right, and I think we nailed it, right? So let's put it back on there, okay? There we go. That is, man, I'm rounding it a little bit here, but y'all can see that, right? That's around, we'll just say 105 grams. Okay, but check it out. Does that mean we have 105 grams of water? It's a good question, and a lot of times students get that wrong. You know, I tell you, we have the beaker as well. That's why we weighed the beaker by itself. So what we got to do here is take that 105. Let me turn this bad boy on. We got to get the 105 minus 56. Easy enough. You can do that in your head. 49 grams of water. So are we 100% accurate? Are we right on the bullseye? No, but for chucks and giggles, we're pretty close. Okay? So what I want to do now, let's take a look at what we're working on here. We're going to do something called the experimental error formula here. And you'll notice I wrote this 49. That's our observed. Okay, 49, in this case, 49 grams of water. What was our expected? That initial hypothesis, if you recall, was 50. 49 minus 50 over 50 again. And that's the formula. I'm not making stuff up, all right? This is just me translating it for you boys. All right, let's rock and roll. Let's solve this. I'm typing in the calculator just to give you a number. I probably could have done this in my head, but I don't know what it's too early in the morning, I suppose. All right, and what do they tell you in math and science classes? Make sure that answer is obvious. -2%, okay? If it's me, I know some teachers and some professors get kind of picky, but for me, right, I don't care if you keep the negative or not. Because if it's 59, I'm sorry, if it was 51, if I had 51 grams of water or if I had 49 grams of water, either way, it's still 1 gram off. So that gives us a 2% error, either way, all right? Now, is that a bad thing? Is that a good thing? Okay, if you're getting the mass of water, no big deal. 49 is pretty close. Our beaker is pretty close. If you are baking a cake and you have just a pinch more sugar or flour or whatever than you are supposed to, whoop-de-doo, right? Heck, if you put more sugar, that's probably a good thing, yo. Now, if you're a pharmacist and you're making drugs that are gonna save people's lives and you're a little bit off, guess what? You might have killed somebody. And that's the whole thing here. This is in the eye of the beholder. Percent error, in this case 2% error, could be very good, it could be very bad. It just depends on how accurate and precise we need to be. And with that said, I'm done. Peace out, boys.